Okay, yeah. So recording is started. So good morning, students. This is a class of geotechnical engineering. Okay. So we are discussing about index properties of soil from last 2 3 classes. Okay. So we already discussed about water content, specific gravity, in-situ density. Fine. And yeah, we are now discussing about particle size distribution. On that note, in the last class we discussed about grade of soil. Also, we have discussed types of soil based on sizes. I guess we have already discussed about what is fine grained soil, what is coarse grained soil, isn't it? And grade of soil, different grade of soil based on composition of fine and coarse, isn't it? So based on that, based on grade of soil, we can find out a soil may be well graded or poorly graded, isn't it? A well graded soil will be what? If it has a representation of all sizes, fine. And in case of poorly graded soil, it have some deficiency or it may have some excess of a particular uh, size, fine. And poorly graded soil again categorized under two types, that is uniformly graded and gap graded or skip graded. I think these things already discussed in the last class. Okay, so today we'll discuss about particle size distribution of coarse grained soil. Fine. So let me share my screen first. My screen is visible, right? Okay, let me first. So we are discussing about yeah, I guess classification of soil. Let me check. Yeah, fine. So yeah, can anyone respond? A screen is visible, right? Yes or no? Okay. Yeah. So we already discussed about classification of soil based on sizes. Okay, that is coarse grained soil, fine grained soil. Hmm. Then grade of soil, different grade of soil. Fine. So main purpose of particle size distribution is to find out grade of soil. Okay, we need to find out whether a soil sample is well graded or uniformly graded or poorly graded. Oh, sorry, or gap graded. Okay, that is our main purpose to find out, and this is funded by a particular experiment that is can be done in laboratory. Okay. Okay, so I think this curve also be discussed with you in the last class. This is a curve that is representing the trend of particles present in a particular soil sample. Okay, it is prepared by putting the value of percentage finer with respect to different sizes. Okay, so how it can be done in laboratory we'll discuss today. Okay, so this curve is known as particle size distribution curve. Okay, this individual uh, drawing is known as curve, and as a whole this graph is known as particle size distribution graph. Okay, fine. I think there should not be any doubt here. Okay, also we have discussed different shape. This curve can take different shape based on different types of grade. Okay, based on the different grade a curve can take different shape. Okay, like this is a uniform well graded soil or well graded sand. Okay, and this is your poorly graded, or sorry, it is maybe a uniformly graded. I think it is written here, no? Uniformly graded, it is also known as poorly graded, you can say. Okay, since uniformly graded soil is a part of or is a type of poorly graded soil. Next, it's also a gap graded. Okay, others you can ignore here for now. So let's yeah. Yeah. So particle size distribution. It is the one of the index properties of soil. Okay. You already got these things. Why it is done? To find out grade of soil. Okay. So let's read it out. The percentage of various sizes of particles in a given dry soil sample is found by a particle size analysis or mechanical analysis. Okay. So particle size distribution is a um, kind of a aim of a particular experiment that is done in laboratory. Okay. And if your soil sample is a coarse grained soil, okay, you can go for sieve analysis. Okay. I think the difference between coarse grained soil and fine grained soil, you already got this in the last class. So for classification or to find out the grade of coarse grained soil, okay, you can go for sieve analysis. And for fine grained soil, you can go for sedimentation analysis. Okay, we'll discuss in later on. Okay. So for now, we'll only discuss about the coarse grained soil classification. That means the particle size distribution for coarse grained soil, which is done by sieve analysis. Okay. In case of coarse grained soil, it may be contain sand and gravel. Okay. And for now, we only considered sand only. Okay. I think from this table you will get the idea. Okay. This fine grained soil, this is coarse grained soil. Okay. Yeah. So sieve analysis. So we'll discuss about sieve analysis. I think you will see this. You can see this picture that is showing here. Okay. This tray type, a circular tray type apparatus, it is known. This apparatus is known as sieve. Okay, sieve. Okay, so there are numbers of sieves are arranged in a particular standard manner. I will tell you how it is arranged in a particular manner. It is fixed one above another. Okay, so if just concentrate on a particular one individual sieve. Okay, now if I say this sieve and the identity or the details of particular or individual sieve is written at the surface. Okay, at the the circumference, or you can say, okay, here it will be written here. Okay, suppose it is written, suppose 2 mm. Okay, suppose this sieve, that is, you can see in the vertical manner, it is rested on the floor. Suppose this on this sieve, it is written as 2 mm IS sieve. Okay, so what does that mean? That means, what is 2 mm? It why it is represent 2 mm? Because can you see this grade pattern? This grade, this cross type of grid pattern is showing here, isn't it? The gap, you can see this box shape. This box shape have a diagonal distance measuring 2 mm. If this is sieve of 2 mm, have you got this idea? This gap is about 2 mm. Okay, that means what you can say, if you say can try to pass some soil sample, or you can just put some soil sample above this tray, some soil may pass through it. Okay, and maybe some soil particle may retain on this sieve. Okay, so what you can understand from the particular small experiment, that means whatever the soil passes through this particular sieve, you can say that soil sample have sizes less than or smaller than 2 mm. That's why they can pass through this. And the soil sample which can retain on particular sieve, okay, we can say that particular soil sample have a size more than 2 mm. Why I have said 2 mm? Because this sieve sizes, this sieve is for 2 mm. That means the gap is only of 2 mm. That means the soil particle which having sizes less than 2 mm, they can only pass through this sieve. Okay, so like that we can numbers of sieves. Okay, I'll show you here. I think one table is here. Let me check. Yeah. So I think this table, we'll discuss about this table. For now, you just concentrate on this first column. So here written IS sieve number or IS sieve in millimeter. So like 4.75 IS sieve is there. They are individual sieves. Okay, 4.75 IS, 4.75 millimeter IS sieve means what? 4.75 IS Indian standard sieve means what? That particular sieve have a grid size say of 4.75 millimeter. Okay, like that we have numbers of sieves. This is one in this represent one sieve. 4 millimeter have different sieve. Okay, others sieve have a this dimension like that. Now just concentrate here. These numbers are decreasing from top to bottom, isn't it? The number say it is a what is the top number is 4.75. Now this 4 it is decreases. Next 3.36 again decreases. Okay, remember this all in millimeter. Okay, next 2.40, then 1.46, 1.2, zero point 0.6 millimeter, zero point 0.3, 1.15, 0.075. Fine. So at the end 0.075 and at the top 4.75. Okay, now I think you can now have an idea about why this higher sieve is placed above and lower sieve placed at bottom. That means the size of the sieve is decreasing from top to bottom. In this manner, we have to arrange this sieve. Okay, we have to arrange the sieve. Say this one for 4.75, this one for 3.36, this one for say 2, this one for say 1 millimeter, this one say 4.5 or like that. Okay, at the bottom 0.075 millimeter or 75 micron. So micron is also a unit of length. Okay, micron. So you just go in Google, you can find out the relation between micron and millimeter. Okay, it's a smaller unit less than millimeter. Okay, 1000 micron is equal to 1 millimeter, I guess. You just cross check in Google. Fine. So I think you have got this idea. These sieves are arranged in a manner such that the higher sieves sizes are placed above and the sizes decreases from top to bottom. At the very bottom, there is a last sieve is called 0.075 millimeter. Now you will get an idea why we have put 4.75 at the top and 0.075 at bottom. What we have will get? What is the main objective to put 4.75 exactly 4.75 millimeter size on size this sieve on the top and 0.750 sorry 0.075 millimeter sieve at the bottom. Just remember these 2 point 4.75 and 0.075. Okay, I'll uh, go back to the last table here. Now if I go for coarse grain soil, if I go for sieve analysis of coarse grain soil, we need to collect the soil which actually coarse grain soil. Now, okay, yeah, fine. So if I go for only sieve analysis of sand, if I go for only sieve analysis of sand or particle size distribution of sandy soil, then we'll what we have to do? We have to consider the soil which have minimum and maximum size of sand. So what is the minimum size of sand? 0.075. Okay, and what is the maximum size of sand? 4.75. Okay, so there is an intermediate size of sand. So what is the maximum size? 4.75 and minimum size is 0.075 millimeter or 75 micron. Okay, to get the classification of sand, we have arranged the sieve in this manner. Okay, 4.75 top, 0.75 at the bottom. Okay, so actually we are discussing about procedure of sieve analysis. Okay, so you will also get this video link and standard manual in your I think it is already available in your student portal in your laboratory classes. Okay, the video is also I think the link is given. Okay, and I think demonstration is also given in your student portal. You just go and check how to find out particle size distribution in laboratory. Okay, so I'll just give you a simple explanation how to do. So what you have to do, first thing you have to arrange this sieves in this manner. I think we have already discussed about that. At the very bottom, we need to put one final pan without any this gap. Okay, just simple pan. It is it's called it is called pan pan. Okay, to collect the final sample. Fine. Then this is the simple procedure of sieve analysis. So what you have to do? First, you have to take, mainly it is done for classifying the soil or to determination of gradation or to find out the grade of soil. What you have to do, you have to take IS sieves, okay, in the standard sieve that we have already discussed. We have to take some dry or air dry pulverized matlab powdered, okay. So we need to find out, we need to collect, we need to take five almost average 500 gram of dry soil sample. And what we have to do, after arranging these sieves, the soil sample should be pour on the top of the sieve, okay. This whole sample will be poured on the top of the sieve, and then it will be shaken up by means of manually or mechanical apparatus. You have to shake for how many time? For 10 to 15 minutes, okay. The suitable amount of pulverized dry soil sample is taken and sieved through different sieves with the help of sieve shaker for 10 to 15 minutes. Sieve shaker means a mechanical apparatus to shake the sieve, or you can also do it manually. Okay. Uh, after that, what will happen? Some soil sample uh, soil sample will pass through it, isn't it? And on each sieves, some soil sample may retain, okay, and some soil sample will pass through its sieve, and finally it will be some soil sample will be written on the final pan, okay. That means we can say on each sieve, maybe, okay, let's say on each sieve some soil particle may retain, okay. Simple is that. No, nothing hard on this. Yeah. So what you have to do, we have to take the weight of soil retained on each sieve, take the measurement of each sieve, okay. Need to find out the soil retained on particular each sieve, take the percentage, then we need to find out percentage finer, okay. We'll discuss this procedure in this tabular format, in this table, okay. That means after the laboratory test, we have to go for preparing this table, okay. How it's done? First, put the value of the sieve on this first column, then find out the weight of the soil retained on each sieve, okay. Suppose on 4.75 millimeter sieve कितना soil retain हुआ measure कर लिया, okay, weight machine में जाके. Like this we have to measure each soil retain on each sieve, okay, like that. Fine. Then you have to convert this on percentage. It's very simple. You need to find out the percentage, how much percentage of total soil sample retained on particular this sieve, this sieve, this sieve, like that. You need to find out percentage retained, okay. Then you need to find out cumulative retain. It is also simple. Just you need to add one by one. Suppose this is suppose 10, 20, 30, okay, let's say 10%, 30%, like that, okay. Then this column will be is equal to this, that is 10, okay. Then this column will be how much? 10 plus 20, that is 30, okay. Then suppose this is 30, this is also 30, okay. So 30 plus 30, put 60, okay. Like this you have to add one by one, one by one. You have to put cumulative percentage written on each sieve. That means say I give you an example. If you don't, if still there is a confusion, suppose I want to find out cumulative percent retain up to this level, that is up to 3.36 millimeter ISC. Okay, percentage retain. What is the difference between this column and this column? This column represents, suppose I only concentrate on suppose third number sieve. Okay, that is 3.36 millimeter ISC. This column represents what is the amount of soil retained on particular this sieve. Fine. Now if I say this cumulative percentage, it represents up to this sieve how much soil retained up to this sieve. That means uh, to fill up this column, you have to consider this shape also, other top shapes also. That means how much percentage finer here, here, and here. That means we need to sum it up all the percentage retained on this shape, this shape, this shape. Then we will find out cumulative percentage for particular this shape. Then like this, suppose for this fourth number shape, you need to add this plus this, then you will get this, like that. So it's called cumulative percentage retained. So how much percentage of soil retained a particular shape, like that. Now we need to find out percentage finer. Percentage finer is simply opposite of percentage retain. Percentage retain means what? Out of 100, how much retain? What is percent finer? Out of 100, how much finer? How much कितना अंदर चला गया, isn't it? That means total is 100. Out of 100, suppose say in percentage, suppose 10 percentage. Okay, cumulative percentage retained on 4.75 millimeter sieve, say 10 percentage. Okay, so if 10% retain हुआ तो final कितना हुआ, 100 minus 10, so here will be 90. Okay, so what about this term? 100 minus this term. For filling this third column, 100 minus this, 100 minus this, like that. So what is percentage final? 100 minus cumulative percent retained for individual seed. Okay, so these things you have to prepare. Okay, after sieve analysis. So from this table, you will get this percentage final and IS sieve, isn't it? After getting this column, you need to find out, you need to plot this curve. We already discussed this curve, right? This curve. See, percentage final in y direction and particle size in x direction. Here you have to put sieve point. That means what is the sieve you have used? Say 4.75. What is the first sieve? 4.75. So it will be somewhere here. 4.75 somewhere here. Okay. On 4.75, what is the percentage final? Is suppose here, this point, like that. So you have to put all these point one by one, then you have to join all these point by a free hand, and automatically one curve will appear. This curve represents particle size distribution curve. Got it? Okay, so like this, say this is your percentage final, this is particle size. Okay, I think we already discussed in the last class. This is done, this is plot in similar graph paper. Okay, why it is called similar graph paper? Because x-axis in a logarithmic scale and y-axis it is in arithmetic scale. Okay, fine. Yeah, you can also put point zero one from here, then 1, sorry, 0.01, 0.11, 10. Okay, don't be confused. You can see here the data are decreasing in this direction, but you can also make alternate. Okay, that is 0.01 you can put here, then 0.1, then 1, then 10, like that. There is a no difference. Okay, you can also go through like this. After, suppose these points you have got from the experiment. Okay, you have to join this point like this. This is represent your particle size distribution curve. Now, how to find out grade of soil? First thing, just seeing this particle size distribution curve, you will have an idea the whether it is well graded or poorly graded. Okay, you can also find out the grade of soil from analytical point of view. Okay, you can also find out. For that, you need to find out first D60, D10, D30. Okay, now what is this value? D10, it represents what? It is a size in millimeters such that 10% of the particular 10% of the particles are finer than that size. D10 also known as effective size. Okay, only D10 is known as effective size, not others. Okay, now how to find out D10, D30, D60? I'll tell you now. Suppose this is a graph that is already appeared in the graph. Okay, now to find out D60, you need to, what you have to do, to first find out that 60%. First, take your pen up to this point, 60%, then go horizontally up to the graph or up to the curve. Okay, then go vertically downward up to the x-axis and find out the point that it's touched in the x-axis. Okay, so this point represents say 2. Okay, since it is increasing in this direction, so let's, it is, since it is 1, then let's say it is 2. So we can say what is the value of d60? D60 value is 2 millimeter. Okay, similarly d30 value kitna hoga? Just go like this from 30% finer and go down. Say, let's say it is how much? It is 0.1, right? Let's say it's 0.4. So we can say what is that value of d30? 0.4. Similarly for d10, say it is 0.09. Since, okay, so like that you can find out d60, d30, and d10. Okay, it's clear. It's just a simple mathematical term. Okay, so what is D represents diameter or sizes. Okay, and what is 10, 30, 60? This represents percentage finer. Okay, always remember, in Viva may be asked. Okay, so yeah, we'll proceed. So after getting the value of D60, D30, D10, why we have find out? Because we can find out grade of soil. Okay, for that a new term will come. We need to find out these two terms. That is uniform coefficient of uniformity and coefficient of curvature. This is denoted by Cu and Cc. Okay, so yeah, how to find out this uniform these two parameter? Cu can be found out by d60 by d10, and Cc, that is coefficient of curvature, it is found out by this formula, that is d30 square. Hold on. Yeah, d30. Yeah, d30 square by d60 multiplied d10. Okay, this is a formula to find out dcu and cc. Why we have why we giving so much attention to this? Because after getting the value of cu and cc, we okay, so we can find out whether it is well graded soil or poorly graded soil. How? Here some recommendation is given here. For well graded soil, Cu, that is coefficient of uniformity, must be greater than 4 if you are doing for gravel, if you are doing sieve analysis for gravel. And if you are doing for sand, this Cu must be greater than 6. Okay. Also, coefficient of curvature, that is Cc, must be in between 1 to 3. These two conditions must be satisfied for well graded soil. If not, we can say this soil is poorly graded soil. Okay. So this formula is also very important in some common exam. They sometimes they ask about this formula. Okay, so you always remember what is cu, what is cu, what is cc. Okay, fine. So you just remember for well graded soil, cu must be greater than 4 for gravel, and must be greater than 6 for sand, and cc must be in between 1 to 3. If this one of the condition is not satisfied, we can say the soil is poorly graded soil. Okay, you can take this next last line is, you can take this as a star mark. For uniformly graded soil, cu is equal to 1. In some exam it is asked actually, that's why I have given here. Okay, for uniformly graded soil, this why is cu equal to 1 for uniformly graded soil? Why? Because see, what is the ratio of cu, that is d60 by d10. Okay, now if the soil is uniformly graded soil, what will happen? The in the shape of the curve, the curve will be, like second, the curve will be steeper. Okay, so imagine the curve is steeper like this. Okay, this the curve will be like this, steeper, like a vertical, almost vertical for uniformly graded soil. In that case, d60, d30, d10 all are come close together. Okay, in case of uniformly graded soil, it is come near to 1. That's why, because d60 value, d10 value are almost similar in that case. That's why कहाँ गया? That's why the ratio of d60 d10 is all nearly equal to 1. Okay, fine. So yeah, this is all about sieve analysis and particle size distribution. Okay, so you can also go through the link that's given in your student portal for how to do the sieve analysis in laboratory to find out grade of soil. So with this, I want to conclude my class here. Is there any doubt? You can ask me. I'll just stop my sharing now. Any doubt till now? Okay, I'm closing the recording. Okay.